Any idea why I picked 9? Because what point here I have highlighted the point 3, 9, and we talked about how inverses work. So if I flip this over the line y equals x, what's its corresponding point? 9, 3, right here, right? And so if I drew its tangent line, we just calculated that that should have slope 1, 6, right? And does it make sense that this line would have slope 6 and this line would have slope 1, 6 based on the whole idea of flipping it over the line y equals x? Does it make sense they would be reciprocals? Because slope here being change in y over change in x, if you flip that over, it wouldn't be too surprising, right? So it seems like there's some relationship between the slopes of these lines. So here's the big question. If I took and totally erased this whole function from your memory, and I said, could we find g prime of 4? Let's pretend we don't know what g is. If we don't know what g is at all, do you think it would be possible to calculate g prime of 4 only knowing what f is? So we're going to take advantage of this relationship right here and say that, okay, g prime of 4 would be the reciprocal, right? So are you okay with me writing 1 over? F prime, and here's the part you got to be careful of, f prime of what? So the temptation people have is to put 4 in there. But that's not right. Because you got to think of how these were related, right? So 4 is really the x-coordinate of g, but if it's the x-coordinate of g, it makes it the y-coordinate of f. And if 4 is the y-coordinate of f, what do you get for x? 2, right? And 2 squared is 4. So what we're trying to kind of figure out is that if I looked at the corresponding point on the other inverse function, I could actually find the derivative of g by kind of doing this, and that would be easy to calculate, right? Again, I don't know what g is. F prime, though, is easy. F prime of 2 is 4, so we'd be actually saying that you get 1/4. Does that kind of fit with this formula if I had put 4 in? Just give me 1/4? I mean, now, we were doing it without trying to use g at all, but now that I want to check it, if I put 4 in here for g, would I get the right answer? Yes. So it turns out that we can take advantage of this relationship because these are inverse functions. And let me just show you, first of all, the formula. And I know there's lots of words here, so my guess is that you might just write this formula down because you definitely need to know it. It always appears on the AP test. And if you're not writing any of the words down, the only other thing to capture about this is that you need to know that f and g have to have some special relationship. This just doesn't, you can't just pick any random f and g functions. This is true when f and g are inverses, right? When f and g are inverses, and in about 5 minutes, I'm going to tell you how you might actually come up with this on your own if you don't memorize it or choose not to memorize it, because for about the first 2 years, I had to go back and kind of memorize it every time I taught this. It wasn't something that just stuck with me, but then I had somebody, I don't know, somewhere I saw how to actually calculate this, and now I can calculate it myself. But before we do that, let me tell you a little bit why we're doing this, and why not just find the the inverse, and then find the derivative and plug in the value. Why would we go through this step? Why not just find, the inverse function and then its derivative? Well, here's a good example of why you need to know this right here. So I copied this from your book, and your book had these directions that are general. I don't want you to kind of lose track of what it is. Here is F. And what they're really asking is, okay, find G prime at square root 2 over 2. And so in the past, I know I've had students that said, why did we go through all this? I'll just go ahead and find the inverse. I know how to do that. You can do that, right? Easy. How do you find the inverse? You switch x and y. And then you could find y. That would actually be relatively easy, right? But when you find y, I say relatively easy, but it would involve what function? Inverse cosine, right? Right. If you plugged a y in here and you had to solve for y, wouldn't you have to get rid of the cosine with an inverse cosine? And then you'd have to find the derivative of inverse cosine. Anybody know the inverse derivative of the inverse cosine? Probably not yet. And it's not something that's really nice. So what I would like to avoid is I would like to know, could I actually find this value without ever having to calculate and use the inverse? And the answer is yes, using our little kind of formula here. And so using the formula, let's talk about it here in a second. Just what we've already done in the formula you just wrote down, this would end up being 1 over f prime. And then this is the question mark, right? What value am I putting in there? Because remember just the example we started out with, going all the way back here. I said the temptation for people is when you're trying to find g prime of 4, they'll remember the 1 over f prime of something. Everybody remembers that. Most people get caught up, and that's why I used a different color and underlined it, is that value. So we need to talk a little bit more about that. All right, so I said, though, before we do that problem that I promised you that maybe I would show you the way now I remember that formula or how I can calculate that formula. So nothing to really write down here, but I hope that you would maybe recall this from your pre-calc teacher or HAT teacher, that this is literally the definition of inverses. And even if you don't recall it, you have to agree with me because this is exactly what, in mathematics terms, when you say they undo each other, that's exactly what this means, right? Because think of my example, like x is your 127. If you, first of all, square it, so that's the function g, and then you take the square root of it, what do you get? 127, what you started with, right? So literally that is, in mathematical terms, what it means to undo each other. That if you took f of g, or for that matter, g of f, they would undo each other and you'd get the variable back that you started with. Right? So are you okay with that's what it means to be inverses? So I think this is kind of slick. This is what, not writing with highlighter. This is how now I would come up with that formula that you just did. Is I'm going to take the derivative of both sides here. Take this relationship, and it would work with doing this one too, it doesn't really matter, but I just took the first one. Take the derivative of both sides. Both of these, you should be able to take the derivative of. Now, there was a lot of hesitation on the right side when I asked, because I made a big deal, and I said, you better know what the derivative with respect to x of x is, and there's a lot of hesitation, but I think I've been getting the right answer all day, so don't let me down. What do you get when you take the derivative of x? Don't overthink it. What's the derivative of x? 1, yes, right? Now, I made it seem like that's the easier side, and maybe it is, but the left side shouldn't be hard because the left side literally is the definition of chain rule, right? It's really the definition of chain rule, right? Derivative of a composite function. So what's chain rule again? Derivative of the outside. Leave the inside the same. Times derivative of the inside. And we're kind of done. Now, usually in a formula, you like to solve it for one of the things. So here, let's go ahead and solve this for g prime. If I solve this for g prime, how will I solve it for g prime? I divide by that. And Voila, right? It seemed appropriate, Kyle, but nobody else was following along. They're still in awe, that's why I took them away. All right, so there's that formula. So now you know what the formula is, hopefully, or you'll either memorize it or know how to find it here. So now you know how to find the formula or come up with a formula. Now the big question is, maybe more importantly, can you actually use the formula, right? She is not here. Liz, they want you in the office. They're taping this for Liz.
Oh, okay. Thank
She's
you.
not really live, I think. She's a little confused. It's electronic Liz. It reminds me of, anybody see The Big Bang Theory when he didn't want to leave his apartment anymore? That's fine. All right. So, can you use that? Now, before we go and try to tackle this, I told you my concern. My concern isn't that you remember the formula, because it's not that tough. It's this value again that I'm worried that you're going to screw up. So this last picture before we go back to our problem is to help you understand a little bit. If you're a picture person, maybe this would help, but I'm just going to use the summary here. That you need to remember this, that the x value for f is really the y value of g, and vice versa, right? I mean, isn't that what we said inverses? You switch the x and y's? So the x of one is the y of the other, or the y of the one is the x of the other. I mean, you kind of understand that? I mean, certainly it's easy to kind of screw up because you're switching them, but remembering that you swap the x and y's would be helpful. You okay with that idea? That's what this picture shows, right? All right, let's see that we can use it. So here, this statement's just telling you that f and g are inverses, right? Fancy way of saying they're inverses. It then just wants you to figure out g prime of a, so I want to find g prime of square root of 2 over 2. So we're not going to calculate g. We're going to use this formula. So it's 1 over f prime, and now the big question is, what goes there? The one thing you will not put there, unless by coincidence it ends up being the same, which could be, but you will not automatically put this number in there, right? You will understand that this is the x value of what function? What is this the x value of? G. I mean, isn't that like, you understand function notation, right? The thing you're putting inside the function is your x coordinate. The thing you get out is your y, right? So this is the x value of g, which would also make it, though, this is the key for us because we're not going to do anything with g, we're not going to find g, but this would make it the y value of f. That's a u there. Right? So it's the y value of f. And what do I really want to know, though? What is this? Think about what I want to find there. What goes here? Again, what goes in the function notation? X value. So I want to find the x value of f. So as long as you keep this straight, which I understand why people mix it up, I mean, it can get confusing, but think about what we said, is you have the y value of f, and you want to find, nope, I didn't write it, the x value of f. If you know the y value of f, can you find the x value of f? Yeah, you plug it in. So I'm going to plug in, what? Square root of 2 over 2 for y. Now, it's a whole different story about your trig skills, but you at least understand this is what you need to do, is you need to solve this equation for x. And after I do, then I'll just plug it in and I'll be in good shape. Because, well, we haven't actually done it, but hopefully you'll understand, and I know time's going to run out here, that f prime is not hard to calculate, right? Right? We can do that before the bell rings. We'll solve this equation tomorrow because we're close. Tell me the derivative of that and we'll call it a day. Because I'm going to eventually need f prime, right? So this would be a good ending. Tell me what f prime is.